So good morning again from the RV Falcor. The time is 7:25 locally. We are at a depth of 4,905 meters. We are currently hovering 80 meters above the seabed, over a cliff which is immediately to the north of the Piccard hydrothermal field, so we're not going any deeper just yet. We're just changing over watch. We've got our new pilot Casey has just taken over from Chris Taylor, and Mario is just replacing James as navigator and co-pilot. So we're getting ready to move off. As you can hear at the watch changeover, there's plenty of chatter in the room, and very soon we'll be getting ready to head over to the BB Vents Black Smokers. Okay, the watch change is complete. We're at a depth of 4,906 meters, 77 meters off the bottom, and we are heading southwest towards the BB Vents mound. It's about 70 meters ahead of us, and about 70 meters beneath us as well. So welcome again to Drive Time Radio on the RV Falcor. We are currently heading across the seafloor. It's 7:30 Monday morning. You're starting the week well with us here at the bottom of the Mid-Cayman Rise. We are headed towards the BB Vents hydrothermal field, or the hydrothermal mound. Our first priority today is to go and relocate a series of 5 high-temperature black smoker chimneys at temperatures very close to 400 degrees Celsius. We're going to sample the end member fluids and some of the chimney from that site first, and then once we've done that, we will be collecting plume samples, doing an experiment, collecting material, both dissolved and particulate material, from increasing heights above the plume, so that we can understand not just the composition of vent fluids themselves, but then also how they react with the surrounding seawater as they migrate up through the water column. And now with the time right on 7:30 on board ship, we are now at a depth of 4960 meters, 13 meters off the bottom, so the bottom should be coming in sight very soon. We should be very close to getting first observation of the seafloor. Seven meters off and closing. Oh, we have the seafloor. I see a large tall structure right in front. A large lump of sulfide dead ahead. So here we are arriving on the seafloor, the depth now 4968 meters. We are on a heading of 215 degrees and facing into the seafloor at the BB Vents hydrothermal mound. So it's taken us 4 weeks since I first flew down to join the ship, but here we are in our second month at sea, and we've made it to 5,000 meters with the ROV. An auspicious moment and a great way to start our last week of the cruise. So moving slowly and steadily forward again, approximately southeast heading, at depth of 4976 meters, and here we see the north slope of the Piccard mound. You can see a bright orange staining of hydrothermal sediment draped over talus and boulders. And what we're going to do now is work our way slowly upslope. We need to come up about 10 meters shallower is where we should come to the top of the mound and see black smokers, but from here there's a good chance what we'll do as we work our way up is we'll come over some diffuse flow sites first. You can see here the bright orange staining of the sediment cover is basically erosion of the mineral deposit that lies upslope ahead of us. What's impressive to think about here is, as far as we know, just about all of this material we're looking at in front of us is pure metal or polymetallic sulfide rich in copper, zinc, lead, a lot of iron as well, of course, which has all been precipitated through hydrothermal fluid rising up from the seafloor, and then over some extensive period, probably thousands, maybe tens of thousands of years, as the chimneys age and die, individual chimneys clog up and fall over. And they leave these boulders, and basically we have a big pile of chimneys, dead chimneys, rock fragments, and then in the extreme then eroding to this soft sediment that we've just stirred up. As we go higher up, we'll see the amount of sediment decrease and the amount of rocky material increase. And here you can see we've moved on to darker rock immediately. The white patches giving our first indication of presumably biological activity, some fluid flow, microbial mats in amongst the rocks. On the top right of your screen, oh, you see the shadow of a fish passing over there. Don't worry, the shadow is much bigger than the fish will be. And up to the right there, you can see some white staining. May well be some fluid flow with shrimp as we get closer, but we just need to carry on upslope here. We're at 4978 meters. Our target depth is about 15 to 20 meters shallower than this. Now we're into really gnarly sulfide boulders, pretty rough terrain that we're traversing over. You can see the long shadows our lights are casting beyond this first boulder. And we continue forward and up. Now we're flying forward again and peering into the distance, and you can see more of this sulfide terrain coming up. So now at 4976 meters, so it's really rough and ragged seafloor that we're flying over. Here you can see these large lumps sticking up, or almost certainly older chimneys. It may actually be in a sawn off block of almost about the size of a tree stump that we're flying over. Still plenty of dead sulfide materials, occasional light patches of staining. Have no sign of any fluid flow yet, but that's only to be expected. We weren't expecting to see any of that till we get up to the deepest sites we've seen are about this depth, actually 4980. So we're keeping our eyes peeled now for when we might start seeing some biological activity as well as geologic mineral deposits. So we're heading forward again, it's just slightly less than 4980 meters. You can see the amount of sediment cover is reducing in places, a lot of talus and a scree slope of rocky material. As we continue up, we'll expect to see less and less sediment and more rocky material. You can see little white patches in the screen now. Probably, if we can see them from this distance, those are maybe Galatheid crabs. Hopefully a sign that we're actually getting close to where the fluid flow is if we're seeing more biological activity. Yeah, I would still keep going on this heading. Okay, let's turn over to the left and have a look at these light patches here. Looks like you're running out of hillside straight ahead, right? Yeah. Well, let's see where we go, and if we recognize something, we might be able to get ourselves oriented of where we are on the map. So we're changing our heading now, coming around more to due south. Basically allowing us to continue to climb uphill. A lot of white material on the boulders here. A different colour of mineral staining, it looks like. Yeah. Yeah, I would. So you can actually see what's coming and.
Very hard to drive sideways across.
Yeah, quite. I think make it as easy as you can to go uphill now. It was. And a navigational error today, once you're getting as zoomed in. What we do know is there's a series of 3 mounds with active chimneys on them at the BP vent site, but also another 4 extinct mounds as well. So by getting ourselves to the top of the hill we're on now, we better work out our relative orientation. Looks like a lot of activity over. Is that white mineralization on the right there? Or just mineral deposit? May just be white mineral staining. Yeah. Sorry, I think that was a false alarm. These are all just dead chimney material. Still climbing now at 4978 meters. Continue to work our way upslope. As you can see, this is pretty much like the Von Dam slope, almost like a 45-degree slope just south of the mound, so although we only got 20 meters, it's not an easy thing to do. You can see really jagged terrain here, probably. Some of this would be extinct chimneys, but just massive sulfide all over the place. Again, our best estimates is there's some thousands of years of deposition that have led to this, all of which has remained as active as the chimneys we're on our way to locate today. And we see some biology, but these are hydroids. These are not indicative of the vent site itself so much as things that can grow on the old rocky substrate that suggests that these things have been around for a while, long enough for things to grow on them and colonize them. The orange color that we see everywhere comes from rusting of the sulfide deposits. So the sulfides are rich in iron. As the sulfides become older and weathered and oxidized, they convert from iron sulfide to iron oxide and change to this rusty orange color. Do you think those are galatheids, Cindy, or anemones? Well, that's a good sign, right? If we're getting close to anemones. It's just like in Brave, right? You follow the little dots through the forest. Oh yeah, it's a very nice example of an anemone top center. It's always a good first tip in vent exploration is you follow the biology, because the animals are living where the good stuff is. So we're continuing upslope now. We're at 4,962 meters. And we're seeing anemones on the seafloor. We've seen one or two galatheid crabs, little bright white patches. There's an eel-pout fish. The sulfide terrain now getting a bit more angular, a bit less sediment between them. Encouraging sign. Not sure what that white thing is. Is that another anemone? And there's a squat lobster. Now we're at 4,961 meters. More anemones ahead of us. So we're continuing upslope, headed southeast. Still very large sulfide blocks be coming up over here. Brief interruption in our camera feed there. There's something pale and white over directly above the super inlet just now. Was that? What do we have on our sonar now? So we've come up off bottom.
I had to come up over a creek.
Yeah.
Then we're next to car and just go up over something big.
What's that straight ahead?
Looks like not. Probably not our header. I don't think we see our header that blue. Oh, yellow's header.
I don't know.
That would suck.
So we've just stopped here on a sedimented bit of hillside. We've just found a piece of what looks like nylon rope or tether close to the seafloor that we do not believe is our own.
Is that what the ship had?
I do not know what they would do. I don't know what that is.
Because they lost it.
They did have 2 attempts at diving here, so do not know what that is. It's very real and right in our way.
That's weird.
Bizarre. Hmm. So we're just orienting ourselves on the seafloor here. We clearly come across this tether we think is left by the Shinkai at the BB Woods mound on their dive a few days ago. And if that's true, we have a target on our sonar. We know there's a large basalt cliff ahead of us. So we're just rotating. Let's hold there because James changed the sonar.
45 degrees from, let me see, 45 right. Okay, now you want to do your sweep back through to the left?
Yeah.
Oh, I'll have to depth that too.
And so we're just spinning now from right to left. And what we can see on our sonar directly ahead is a long linear feature which would correspond to a basalt cliff that we worked our way up and down. On our previous dives when we were here in 2012. Now heading due east, and we can see the sonar to the right of us.
Could you go a little more forward? Yeah, I'm dropping down. Okay, cool. Right now, it definitely drops off.
I don't think we've got anything strong enough to cut it with. So as you can see from our views on the camera right now, we basically have a significant trip hazard in front of us. We suspect it's probably the optical fiber that the Shinkai used for their telepresence work earlier. So we are going to just turn to our right and pull away from this. And then we'll continue west. Yep, I think if we head out towards the west from here, Casey, for just a few tens of meters, and then we'll think about where we go from there. Large extinct chimney ahead. So then, James, should we keep... Let's think. Coming around to due south now. We should keep curling around through west and eventually north? Or
I think that. Do we think we're where we are on the overlay there? I think
yeah, I think the USBL navigation looks pretty good.
plus or minus 20 on the US.
I think that sonar did look like we were right at that cliff face, or coming up, approaching that cliff face. So we're to the southeast of the BB Woods site right now, that southwestmost mound. So we want to, I would suggest we come out around that.
So if we go
Yeah, in a big loop round, yeah.
and I think
So we do like a big 270 circle around.
come out and acquire a contour and go in like that, and that's basically find a line. While Casey's maneuvering his way out, Chris, perhaps you and I want to get notes in the log real quick, but you and I can kind of identify a contour we want to move on.
I think, and for now, 4970 isn't a bad starting point.
So I want to come over. So I think that I agree with Casey. Kind of.
So we're progressing now. We're flying out into Midwater. We have moved away from the yellow cable that we found running across the seafloor. We're pretty confident that was running northeast to southwest to the southeast of the BB Woods mound, close to a large vertical cliff in the basalt, a large fracture that we know runs right through the middle of this area. So now what we're going to do is do a large arc through about 270 degrees, passing from heading south through to bending around to the west and eventually round to the north, and heading back towards where we should expect to find the BB vents chimneys. that's probably the way to go, is trust our USBL navigation isn't lying to us. So if we come out till we're west of the mound that's immediately north of us right now, and then we can come round to the north up the west side of it.
So do we want to shoot in a little gully there between woods and vents?
I would,
Or do we
well,
want to try to go all the way up
and
and do a reapproach? Because you want it to be on the north side anyway.
yeah, we do when we get there. If we want to be able to sample the fluids, we need to come at it from the north side. Maybe we came right out to, you see where the grid line is that comes down, that's ahead of you?
Yeah.
If we went north up there and then came in from the west,
Just
and then,
facing right down the slope and then like no.
yeah, that might be the way to do it.
Yeah, I think that's a very good idea.
So we'll stay away from the edge of this nearer mound that way. And at this contour, then we should actually see it. Yeah, as we get up there, we might get a bit shallow, but we can look for it on the sonar as well. We'll see as we get close to the mound. Then we should see it on our starboard side as we approach. So the time is 8:20 on the RV Falcor. We've been on the seafloor about 45 minutes or so, I believe. We have ourselves oriented now. We've made sure our navigation is working correctly. We have encountered one little trip hazard to the southern end of where we wanted to be working today. So we're just moving away from that. We're flying out in Midwater to get away from a cable we found lying across the seafloor. And we're cycling around again. First we went southwest, then west. We're now headed northwest. And we're going to then head north and go about another 100 meters through the water column. And then we're going to home in again on the vent sites that we have come here to sample today. So according to our navigation now, we are at a depth of 4971 meters, 40 meters off the bottom, flying north-northeast. We're passing by to the west of the BB Woods Mound, which is where Ken Takai dived with the Shinkai a few days ago. And we are headed towards the BB Vents Mound, where the highest temperature black smokers are, which is our primary objective for today, to sample those fluids. So we can't see much in the cameras, I admit, right now, but what we just did was rotate the vehicle and look on the sonar and got confirmation that about 50 meters out to our north and east, there's a target face, so that is actually what we're expecting to intercept the vent site on top of its hydrothermal mound. So now we're continuing about another 30 or 40 meters north, and then we'll rotate to the east and head upslope. So it's 0830, at depth remains 4970, altitude now is 30 meters, so we're flying along the 5,000 meter contour, moving upslope as we're along this heading, coming up on the west side of the BB Vents mound. So we're now at 4980 meters, 16 meters off bottom. We have some sonar targets coming up straight ahead, which will be consistent with the northwest edge of the BB Vents mound.
What's the range of those targets? 10 meters per division, so about 15 meters away. Roger.
So sonar target's about 15 meters ahead, and oh yeah, we have the seafloor in sight here, and sulfide lumps.
Is that what we expect?
Yeah, at these depths it should be dead extinct stuff here. What's that orientation? We're on heading northeast. Hmm?
Thought we were gonna crash and flop somewhere up there. Maybe probably.
So touch down gently at 4,990 meters. Heading northeast, we think we're on the southwest corner of the BB Vents mound. So I think just staying on this orientation, Casey, and just head up slope and get ourselves oriented from there. Yeah, because if we get to the point where we can see the chimneys, we can then just come around them to the left, round to the north side. But there should be a few tens of meters upslope on this heading. we're just working our way upslope now, heading northeast. Depth is 4990 meters over extinct massive sulfides, with a dusting of reddy orange iron oxide material. The grey clasts you can see here are the fresher sulfide material. That's the colour of what the chimneys are made of as they precipitate, rich in copper and zinc and lead sulfides, and iron as well, of course. And then as they sit on the seafloor, they become oxidized and weather away to form this yellowy orange sediment. So we think we now know where the Shinkai cable broke, because we can see the end of the cable
The target is target.
draped over a piece of rock.
So it is on target. It's exactly on target. If you are 6 meters away.
Okay. So 4963 meters,
Well, that's good to know that the line.
and we've actually got the end of it, and it's not a continuous line. And now we're rising up above that, so then our float pack and everything's higher than that hazard. So we're now at a depth of 4961 meters. Seeing some white discoloration in the sulfides directly ahead of us. We're facing close to due north. We end up on the south side of the chimneys, or the BB vents mound, which wasn't necessarily where we wanted to be, but that's the way we came to avoid the trip hazard of the Shinkai umbilical that had been left behind. And we're beginning to see some anemones, which is hopefully a good sign. And more biological activity directly ahead. What do we have on our sonar now? Oh, there's more umbilical. So, if we just stop there a minute, if we rotate to the right, Casey, I think we could see some. So we can see we've just come across more of this umbilical as we came upslope. We thought we'd seen the last of it and we were safe to proceed. So we've risen over that next lot of Shinkai umbilical cable, and we're continuing upslope. High concentrations of anemones on the patch of rock dead ahead. We're coming up on the kind of depth where we expected to find the chimneys. There you can see the view out the front. Looks like we're heading in the right direction. We have sonar targets just off to our right. High patches of white stuff over that direction. Some microbial filament on some of these rocks, as well as the higher concentration of anemones. There's microbial filament on the rocks here. It looks like the furry walls area. Let's just keep heading upslope here. Yep. It's diffuse flows, I think just keep coming upslope. And we're heading north here. Yep.
Occurred to me that Meg maybe had requested a sulfide that Max was supposed to bring back.
Yeah, we'd get that from the same chimneys that we get the fluids from. Okay. So can we keep going forward and upslope there? Is that putting ourselves in harm's way? Can we go forward and uphill without doubling back on ourselves too much? Mm-hmm.
Shame you don't want it
Hmm. Well, I think we're in good shape because when we were facing south on an anemone field, we were just about 10 meters downslope from the black smoker chimneys when we were here last year. We spent a couple of hours collecting anemones like this. Hmm? Right, now is that our dust or is that real black smoke on the right? Okay. And that looks like we're lifting off the bottom. That's downhill ahead of us, right? So we
believe that, we need to come back.
yeah, we need to come back around to the right again. So we're still wrestling with our navigation both in XY and in depth, but we're flying over areas of extensive bacterial mat and shimmering flow and very dense anemone fields. This isn't what we remember from the Black Smoker site, but it would be consistent with being on the BBC mound. So, just so you know what we're doing here on the Falcor, the time is 9:15 aboard ship. We've had some trouble with our navigation working out exactly where we are, and of course we've also had to take some evasive action to avoid 2 sets of cables we found on the seafloor left behind from the Shinkai's telepresence activities earlier in the week. We're now calculating a range and bearing of where we think we might be. We basically have 2 separate mounds adjacent to each other. We know we're on the northwest flank of one of those 2, facing out into deep water directly ahead, and we're going to take a short vector now, heading along a bearing of 300 degrees. We're either going to go from the low temperature mound to the high temperature mound, or from the high temperature mound out into deep water. And the next move should help resolve that. So we're starting our move now. We're moving on heading 300 degrees, and we're going to move 30 meters when we go. And away we go over more fields of dense anemones and bacterial mat draped over jagged and angular sulfide rocks. So we're still at 4960 meters as we head this way, and the altitude is only 4 meters. Still at 4960, 6 to 7 meters of water beneath us. We've moved 25 meters, 5 more meters left on this move. Okay, so we're now dropping down. We're at 49.60 and 15 meters off the bottom, so we're going to come down a little bit lower and then sweep left with our sonar.
I mean, at least nothing's explosive down here.
So we're seeing something.
Yeah, it's right here. We were right at where we
Got something 10 meters out.
Is that directly ahead or off to port?
It's slightly off the port.
So we have a
right to where we want to go.
sonar target about 10 meters ahead of us, slightly off to port. We're just going to rotate another 45 degrees and then head towards it. And we'll be heading southwest. Mhm.
What does that do for our targeting? Go there.
USBL would put us.
Closing in on our target now, less than 10 meters ahead. at a depth of 4970.
The only thing I can say is, yeah, go up and do it.
Do we think it's up high?
I don't
Yeah, do you
know
want
the
to?
feeling to it.
Just went down a little bit.
Yeah, I think
It's up higher.
it's better to let the target come to you, right?
Hoping for the sharp tail. Hit something.
So here we are at 4983 meters, facing a dead chimney on a heading of 221 degrees. So this was the ideal orientation. If to have more targets uphill, if we come up a little bit and forward.
Hit some stuff.
So it is. Thank you. It's 9:30 on the RV Falcor. We are cycling around the Piccard hydrothermal field, having some problems with our navigation. So we are currently trying to orient ourselves. The USBL navigation screen keeps jumping us around and disorienting us. We're pretty sure we located the BBC hydrothermal field, but the whole thing, the vents are on the edge of a precipice, so we're continuously moving over gnarly terrain, trying to get ourselves locked into where the active vent site is. Okay, so based on we carried on the southwest orientation, the combination of depth and altitude got to 5,000 meters. So we know we're in crossing the 5,000 meter contour is heading the wrong way. So we're going to swing around, do a banked curve, 180 degree, and then head back to the northeast to reacquire the mound. Okay, we're going to switch out commentary on what we're doing during this dive for a while now. Then I can spend all my efforts with Casey and James getting ourselves navigated, and we're going to get Julie Hoover, I believe, is going to come in and spend some time relaying to you ashore what we're doing.
Just going at 60 up, and I want to kind of just.
So the reason you are only seeing black out there is because we're
just above the vent field, moving to where the black smokers are. And it's safer for Nereus to travel up in the water column rather than move around all those massive rocks and sulfides and things that we could get our cable caught on. So just beneath us, all the interesting stuff is happening. But this is the safer way to get to where we need to go.
We also have lights off. For saving power.
And we also have lights off because we're saving power. Nereus runs on battery power. So we want to conserve that so we can use it for taking samples, and we have to make sure we have enough battery power to get back as well. All right, we are starting a move east-northeast, 50 meters, and we are looking for the VV vents mound, where we have high temperature smokers that we want to sample for Jeff Seawald and his student, Joel McDermott, and for Chip Breyer to look at geochemistry, mineralogy, things like that. So we started making the move through the water column again. That's why you can't see anything on the seafloor. But I promise it's there. All right, the seafloor is coming up beneath us as we're making this move in the water column to the BB vents mound, where we are searching for black smokers. We know they're there. Just getting our bearings with this vehicle on the seafloor. And once we arrive on site, we'll be doing some black smoker sampling. We also have our lights turned down to save power, but we'll turn them back on when we get back to the seafloor. I can see the navigation screen, which you can't see. Looks a little bit like an old-fashioned video game showing a little Nereus moving across contours of the seafloor where we have our targets marked. And it shows our depth and our heading. It shows the altitude of the vehicle above the seafloor. And we also have a sonar that, sonar? Is it called a sonar? Yeah, that looks forward so we don't run into anything. And now we have the bottom in sight.
So we might be getting back into the area where
We need to keep an eye out for any hazards, including stuff other people have left on the seafloor, or large sulfides, hot fluids. Those are all things we don't want to get our vehicle or our cable stuck in. So one good way to look for venting is to look for animals like these anemones or shrimp or furry microbial mat. That's usually a sign of venting occurring.
How far did we just move?
We just moved 16, 15 meters on the ouch.
That's right on.
That's according to what DBL, so we got to take a grain of salt with what Mario do. We're gonna be able to-
For whatever it's worth, we know anything about the current. The current is going sort of
Yeah,
west
so
to southeast. So like, I just drift.
Okay.
No, I put it in the revised.
That may be false. That may just be.
Good job, Jeff. Good logging. Jeff Seawald is next to me logging. He's noting that we see an anemone. We're pausing the vehicle, make sure we have our bearings. If Casey lets go of the controls, he's getting pushed a little bit so we can figure out which way the currents are pushing the vehicle.
Well, I'm not, I think we're so close to this target now, it's just, we can turn, we can sweep it out when you see if it falls, just sweep toward it and see if it falls off. And again, Casey's got a hull.
It's where they're uphill.
He's got-
You think where they are right now. If we go east, we're going to go between the mountains. If we go northeast, we're going to go.
But the case is also right up against this feature right now, so it does kind of dominate the song.
So should we just go on ahead and go 4-5?
And what I'm thinking is through here, kind of go up on all four bottom, go for 20 meters. 20
So all this orange stuff we're staring at,
That'll give us more, so going a bit north here will give us more terrain. What I was thinking of is we set ourselves up for a roster.
Also keep in mind that we don't want to drive back and forth over that vehicle.
so we're planning our move, sitting here in front of this large, very, very weathered sulfide mound. I'm going to ask Jeff Seawald here. So basalt gets weathered as it ages, right? And we're looking at basically rust on the seafloor, iron.
Yeah, this might be sulfide, metalliferous sediment.
Metalliferous sediments. So fallout from the black smokers falls back and it coats the rocks. And there's actually a lot of microbes that can oxidize that iron and other metals and use it as an energy source. It also makes navigating difficult because anytime you just even lightly touch the bottom or the thrusters interact, you get all these clouds of red and brownish smoke. But what we're really looking for is black smoke, where the fluids are exiting the seafloor. 20 meters which way?
We're heading 010.
All right. So we're heading almost due north, 010, about 20 more meters where we think our target is. Looking at all these weathered sulfide deposits with metalliferous sediments on them, which makes navigating a little bit tough, but we can do it. We've turned our lights back on. We've got our fancy Hollywood cameras running. These cameras were donated to Hui along with the Deep Sea Challenger by James Cameron. Nice high def view of the seafloor at 5,000 meters. Seeing a few more anemones as we move north up this pretty steep cliff, right? So we're pretty much going vertically up and trying to make a little bit of a northward trek as well. One of the reasons we want to sample these hot smokers is to get a better constraint on how many, that's not the right word, the concentration of metals coming out and the impact that might have on deep sea processes. Looks like we're making it toward the top. You can see a little bit of white furry microbial mat there. Those are, oh, and there's our friend the yellow cable that we want to avoid.
So what we did before was we followed the cable up and around.
And I think that's probably what takes us away from where we want to be.
Right. So I think we should probably just want to cross it.
Fly up and over it.
So the question is, where is
So we're just trying to figure out the safest way to get over this. We believe a fiber optic cable left behind.
oh, it's pretty on the bottom down there.
Yeah.
I think we're just going to go up and over it, but we definitely don't want to get it caught on our vehicle or our cable. Whoop, up we go. So we see a lot of white staining on the rocks here. It's a good indication that we're near venting.
These large, we're going over the cable now.
So we're going over the cable now.
We probably did exactly what we did. They just flew their cable all the way around, so we keep following it.
You can see more
Well, I think that's it by
little
avoiding that cable, we
anemones.
probably went in exactly the wrong direction.
Interestingly, at the site 20 kilometers away, 2,500 meters more shallow than this site, we don't see anemones, which is kind of interesting. We see shrimp at both places, but we only see anemones here. And why that is, we're not sure.
Yeah. Which heading we are? We're still going north now. I would have a spin a little to the east, but turn to the right, just check out the sonar. There's a danger we could fly past the top of the mound.
No, that can't be very high.
Yeah, I think it might have happened
So
several times before.
we use a combination of visual on the seafloor and sonar to help us find our targets.
Follow the
We really you're only seeing one point of view, but in the van here we have a couple other cameras. So if you look, there's a lot more venting off in the camera down there. There we go. All right, now we're coming into a bigger area of active flow. Looks like a big flange.
Can we keep
Yeah,
turning
I'm
to the
just
right?
trying, I don't want to turn it
No,
up.
fine. I think we now want to go up in that direction.
All right, so we can see a lot of this.
This stuff is on the north side of the where the this is north of the chimneys. This kind of furry wall material. So I'm not trusting the USDL fix behind it.
Well, right now, I mean, Chris, this is on, I mean, right
Okay,
now
let's
we're
hold
facing
let's hold
north.
on.
This white staining,
Where are we facing? We're facing northeast.
we're seeing two things on the rocks. You're seeing anemones to the left and to the right. That's
Okay, let's
basically
hold.
microbes that are attached to the rock surface.
Decision what to do.
I mean, right now we're
And we collected some of this rock last year on our cruise here. And in my lab back in Woods Hole, we sequenced it. And it belongs to a group of proteobacteria that are oxidizing sulfur. So these fluids here are really rich in hydrogen sulfide and other sulfur species, and we think that's how they're making a living. But they're really solidly attached to that rock, almost like glue. We had to use a razor to scrape them off the rock. And that's a really good way to make a living if you're a microbe living at the bottom of the ocean. Because then the fluid flow won't take you away and you're constantly fixed right where all the yummy food is coming past you from the vent fluid and from seawater around you. The deep sea, good place to be a microbe.
Yeah. But they're also just before you get to the chimney. They're kind of like they're just west of
Just
the
pausing here to get our bearings. Again, we're looking for the black smokers that we know are here. A nice zoom in of this microbial mat and the anemones. There's very, very light fluid flow here. It's hard to see, but if we were to stick our temperature probe down into those cracks, we'd probably see a couple degree temperature anomaly. So the bottom seawater here is around 4 or 5 degrees Celsius. You can see those thick filaments waving in the, looks like they're waving in the wind, but they're waving in the water. You can see some shimmery flow down to the right. We have our navigator, James Kinsey from Woods Hole. Pilot, Casey. Sitting next to Casey is Mario. They're all part of the Nereus team, helping make sure we're moving the vehicle right, not putting it in danger, and getting some samples.
Hmm?
But I was hoping you're going to say,
You're right.
got good feelings about right.
Okay. Let's do that.
Turning right all day.
Hasn't been wrong yet.
Not an ambi turner.
So we're swinging to the right. Again, you can see a little bit of shimmery flow there, but what we're in search of is 398 degrees Celsius fluid. Is what we measured here in 2012, right?
Probably not as turn as one. You can bag him. I mean, is orange good? Is that bad? Are those shrimp?
heading heading to the east at about 80 degrees, moving uphill, where we believe our target for the smokers are. It's really pretty anemones. Anemones are filter feeders, I think. Right? Filter feeders? They're filtering things out of the water column and eating them. Last year when we dissected one of these anemones, they found, Cindy Vandover and her group found a shrimp in its gut. So we're at the top of this mound now.
Okay, let's hold up there a moment.
We're going to hold up, get our bearings. We're at 4950 meters. Just as a reminder, these are the world's deepest hydrothermal vents. Behind me, James and Chris are looking at their maps, getting our bearings. You know, we don't have a GPS at the seafloor. We have to use something called USBL, ultra short baseline navigation. Basically, we have a pole hanging off the bottom of the ship that tracks the vehicle, but it's sort of at its limits at 5,000 meters, so it makes navigation tough. Radio doesn't travel well in water, so we can't use that either. So navigating on the seafloor is hard.
Yeah, so Shrimp Gully's depth would be Shrimp Gully would be at 4940. Now we're in USBL in front. And the
We're sitting
mound
right
would
in
be
the gap.
30 meters ahead of us.
USBL would have us right now.
So we came up over this lump and went straight ahead. We should find a shallower match.
Right, we're facing 77, yeah, we try.
Maybe due east from here.
Due east. We should see sea rise.
Might be about a smart movement. I can think about it.
I'd say here's what one strategy at this point. Here. A high, drop off. That's going to give us a lot.
Yeah.
We have to, we know we have to lie somewhere along. Like we just use 15% line slot.
Yeah.
And then the idea of them we need to will go up, so get to there. Maybe that get there.
Hey, what's that over to our right side? Right bottom?
That's a smoker.
All right. We have a smoker in view.
We've been
That's,
sitting
so
like
now we're not at BBC.
Oh,
Well spotted, Jimmy.
bang a couple more light.
Turn in right is a good way to go.
we are churning to the right. We spotted some smoke to the right of the vehicle. Now you can see it coming into your screen. There we go. That's the black smoke we've been looking for. And there we are at BB Vents.
4 of them in a row.
Turning on some lights, trying to get the best view here.
So you want the one all the way to the right?
There's a lot of particles up in the water column that are reflecting.
You're on the west side of the town. So there's a series of, there should be 4 of them, and then a big lump of rock just past them.
So there's basically 4 chimneys in a row here.
So I am facing east. Okay.
Right. So there's 4 of them running uphill. We want the most uphill one, but the way we sampled it last year, there's a big lump of rock just uphill from it. So we came round the top of the rock that way and came at it.
So we are.
So we're here right now.
So the fluids coming out of these chimneys, last year we measured them at 398 degrees Celsius.
So Casey, we're probably like there right now.
Beneath the seafloor, it's likely much, much, much hotter. These fluids are loaded in hydrogen, which is a good food for microbes. And they're also have a lot of iron in them and a lot of hydrogen sulfide.
It looks like smoke's going down. Going
Yeah, they
to my
slope
right.
downhill to the right. If you try and go around them, you end up going over the smoke of all the other chimneys.
So we're just figuring out the best way to approach them with the vehicle. Again, we need to not melt anything, including our fiber optic cable that allows us to see the seafloor and control the vehicle. Gives us our telemetry. Can see a few shrimp, and there's a lot of smoke in the way, but where these fluids are leaking out of cracks and mixing with seawater, there's a lot of shrimp living on the chimney surfaces, and they have chemosynthetic bacteria living in and on them that are basically the food that those shrimp eat. So there's a really pretty view of these spires that are pumping out black smoke. As you can imagine, this is you got to find the best approach where you can actually see where the fluid's coming out. And we want to try to get our samples as close to the vent orifice if we could. That's called the plume, where the hot fluid is coming out.
Okay, we saw him.
Oh, really?
Hope you watch it in the library.
So we're just repositioning, trying to make the best approach to the chimneys so that we can sample them. So we are at the BB vents. For those of you just getting your morning coffee, we're at the world's deepest hydrothermal vents, at the Mid-Cayman Rise. If you look at a map of Cuba, you see a little island, Grand Cayman. We're just south of there at a site called Piccard. There's 3 different vent fields down here. We found them in 2009 and 2012 along with our British colleagues. And we are here to sample high temperature black smoker fluids. And we are just maneuvering the vehicle to make the best approach to sample Those long pieces of rock on the seafloor are broken off pieces of chimney. These chimneys can grow extremely fast. As long as they have a hot source for fluids, they pump out, and when they hit seawater, a lot of minerals precipitate. And all the orange stuff you're seeing is metalliferous sediments, buzzword for the day. Just basically fallout from those black smokers settling on the rocks. We're moving our way back up the mound, try to position ourselves to take samples. Nereus has thrusters, correct, on the back? And those thrusters are what make it possible to move laterally and vertically. But it also often gets a bunch of junk caught in it that stirs up a storm like what you're seeing on your screen right now. We're just waiting for these particles to clear so that we can get set up for sampling the black smokers. Again, we're at 4955 meters beneath the surface at the Piccard hydrothermal vent field. We're at a place called BB Vents, B-E-E-B-E-E. And we want to sample these vent fluids, just trying to figure out the best approach. We're using a vehicle Nereus that has a very light, thin fiber optic cable behind it that we have to be very careful not to melt or break. Nereus has been to the deepest point in the oceans. It's been to the Mariana Trench. So it's been to 11,000 meters. So 5,000 meters should be a piece of cake. Have our smoke off to the right of the vehicle, maybe. Ugh. I've had a challenge this morning navigating around a fiber optic tether that a previous submarine left behind that we don't want to get caught in our vehicle or a cable. You can see it right in the middle of your screen right now. can see a group of shrimp in front of us. And where you see swarming shrimp usually means there is warm hydrothermal fluid leaking out because the shrimp have chemosynthetic bacteria living on and in them. Before hydrothermal vents were discovered in 1977, nobody even knew that chemosynthetic ecosystems could exist. And we now know they are everywhere along the world's mid-ocean ridges, which is about 50,000 kilometers long. Goes through the mid-Atlantic, down through the Indian, around Antarctica, and up into the Pacific Ocean. You might have seen pictures of large tube worms at some hydrothermal sites. We don't see any of those at Piccard. We're not sure why. One idea, one hypothesis is that because of the extreme depth, for some reason they can't live here. So we're continuing our move up this mound. Again, looking for the black smoker. It's off to our left now, I think, right? Yeah. You can see those beautiful pipe-like chimneys. Again, those sulfides are formed when the minerals precipitate out of the hot fluid when they hit cold seawater. You can see there are a lot of particles in the water column. We're basically, right in front of our basket. So to the left, we have black smoke, trying to back away from it so we're not right on top of it. see some anemone, some shrimp. The bottom of this sulfide mound, at the top of it is the black smoke. Tons of particles in the water column here from those black smokes pumping out all those metal-rich fluids. And they fall back down onto the rocks. Thanks. Yeah, good job. I like this one better. Yeah. So again, we're moving up the face of this massive sulfide mound to get in the right position for sampling the black smoke. You can see shrimp gathering in areas where the fluid's leaking out of the side. There's a large clump over there. They have to position themselves just perfectly where it's not too hot, but they're still getting the hydrogen sulfide that their chemosynthetic bacteria need to oxidize the sulfide using oxygen from seawater to make organic carbon. That organic carbon is then what feeds the shrimp. It's just like you eating a hamburger, just more complicated. Passing over the fiber optic cable that Shinkai left behind. That's a nice big swarm of shrimp over there. Last year when we were here in 2012, we did a lot of temperature probing, and I believe we figured out the shrimp can't live in fluids above about 22 degrees Celsius. Does that sound about right? Right now they're getting scared off by Nereus. Lots of shrimp. One of our goals on this dive is to slurp up some of those shrimp with our suction sampler, our mini vacuum cleaner on Nereus. Hopefully be doing that later. Right now we're waiting for the particles to settle. We've got smoke coming out up top, and then the particles fall out. And every time our thrusters get near them, it creates a little mini dust storm, basically. We also have currents moving around. It's not an easy place to work. A little bit of microbial mat up in the left part of your screen. Those white filaments you see waving. Again, those microbes are living attached to the surface of that rock, oxidizing sulfide, we think. Most of the bacteria down here are autotrophs. That means they fix carbon dioxide instead of eating organic carbon, similar to photosynthetic life up on the surface, which fixes inorganic carbon, versus us, we're heterotrophs, we eat carbon, we can't make our own carbon. But at the seafloor, there's no light, so instead of using light energy, they use chemical energy, or hydrogen sulfide, or methane, hydrogen, iron, lots of different energy sources for chemosynthesis to occur.
Jim, what was the depth of the black vibration? Yeah, 4950. Yeah.
These are pieces of broken sulfide on the seafloor. These chimneys can grow very quickly.
4950?
Yeah, we're about 7 meters beneath where we need to be. And those rocks that you're looking at are basically broken off spires from the sulfide chimneys. They fall to the seafloor and they grow back, and then they fall and they grow back. And as long as you still have a heat source deep beneath the seafloor, a magma chamber of some sort, you can get these large chimneys. And they only die away when that, for some reason, that path between the hot magma chamber and the seafloor disappears.
Can we try not to gesture like right here? We've both been doing it for like an hour. And I just feel like, am I on a reasonable heading here? They run north.
What was our heading when we saw them the first time?
Southeast to northwest.
So we should be pointed right at.
Okay. Our heading was 80.5 when we first saw them to the right.
We were on the west side of the moon.
Okay. So we're using a combination of depth, previous maps we've made here, and our heading to figure out where we are, and trying to figure out the best position for getting our samples. As I mentioned before, Nereus has a very light fiber optic tether. It looks like a fishing line hanging on our backside, kind of the top back part of the vehicle. And we have to be very careful not to wrap that fiber or to melt it. This is actually one of the most challenging environments to use any remotely operated vehicle because there's so many hazards. 400 degrees Celsius fluid, large peaks, cliffs, lots of things to get hooked up on, as we've seen, since we have a fiber optic cable left behind by Shinkai from their dive here a couple days ago. Those are large broken pieces of sulfide on the seafloor from chimneys tumbling over. That sort of looks like a different type of sediment. It's not as red.
I would say northwest.
Target of
Okay.
Targets there
All right.
that are sitting less than 10.
Okay.
So I think what we want, but I think what we want to do here is if we're moving and we're, already moving and we're going down slope. That's the way I keep it on.
Right. So once you get to 4950, right, so this is how we want to go upslope.
Right. So the moon is going down slope.
when we were facing this heading, when we were facing east before, at 4950, we had a big field of anemone. And now we have depth of spot, so it's been tapping the backside of the BBC. So I would, yeah.
I don't know. So we're moving back to the west, to the north. Again, trying to set up our positioning here. It's very treacherous terrain. Trying to position ourselves correctly here. A lot of massive rocks here. Some white staining on them. Looks mineral. We're at 4960. Yeah. Need to get up to 4950 where the smokers are. Back in an area with a little more red staining on the rocks. So in the van with me, I have Jill McDermott. She's a graduate student in Jeff Seawald's lab at HUI, MIT. She's logging things so we can keep track of everything we're doing on the dive. And to my left, I have Casey, James, Mario. They're all part of the Nereus team. Casey's driving the vehicle and James is our navigator. Mario is keeping an eye on all the sensors and batteries and making sure the vehicle is safe. And then Chief Scientist Chris Derman, also to my left, the guy with the British accent. It's helping James figure out where we are. Chris knows this spot better than any of us. It's a pretty flange or something. What? With hydroids on them? You can see some anemones off in the distance from the brow cam, or whatever camera that is. You can't see that camera. The camera you can see is was donated to HUI by James Cameron of Titanic and Avatar fame. We built a fancy submarine and donated it to HUI, and we stole the lights and the cameras with his permission. You can see some white microbial filaments on these rocks and a lot of anemones behind them. Usually means we're getting into an area of venting. Oh, it's so pretty. It's really, really pretty. Last year we collected some of those rocks and we had to scrape off the filaments using a razor because it's almost like they're super glued on there. Microbes can excrete a lot of exopolysaccharides and other things to anchor themselves onto the rocks. And once they're in place, they're at a nice interface for getting good energy sources from the venting fluids and from the seawater. This area is just covered in it, and we can see smoke coming from somewhere. Maybe to our right. see everything in the screen is getting clouded with that black smoke. And that shimmering you're seeing, it's not a trick of your eyes. That's lower temperature, what we call diffuse flow. Around here, a lot of these vents are about 50 degrees C. This is it's a really beautiful view here of microbial mat and anemones and shrimp. And this is a area that we visited last year. Just trying to get you some beautiful eye candy this morning. The world's deepest hydrothermal vents. Doesn't really look like maybe the types of vents you're used to looking at, where there's large tube worms and clams. These hydrothermal vents have shrimp and anemones and microbial mat. So this myriad of whitish, orangish stuff that's anemones and microbial mat and tiny little shrimp living on these surfaces. Look at all those beautiful microbes living at the bottom of the ocean. Actually see those types of microbial mats in lots of different environments where you have hydrogen sulfide. So we see them in cold seeps. We see them in terrestrial hot springs like Yellowstone. Some of the volcanic hot springs up in Iceland. Lots of places. How they're all related to one another, we don't exactly know. But usually when you have a nice redox gradient with lots of hydrogen sulfide and lots of oxygen, you see these types of microbes. And in case you couldn't notice, I'm a microbiologist. Don't ask me anything about the animals, because I might be wrong. So someone on Twitter is asking a question. Should I answer via Twitter or should I answer via now? They're asking if these organisms have been identified and classified. Cindy Van Dover from Duke and John Copley and Paul Tyler from the UK have been classifying these organisms. They use a combination of molecular biology, looking at the DNA, and also looking at their morphology. So how many arms, how many legs, length of carapace, how many antennae, things like that. So yes, things are being classified that way. And we're doing a similar thing with the microbes. It's a little bit more complicated with the microbes because morphology doesn't tell us much. They kind of all look alike, little circles or little rods. So we use a lot of molecular biology to help us identify them as well.
So, I know what I was doing when you guys were I can't remember, I was trying to jot down relative things, how it's space. So I have, right, just when we were at the last moment, that's why I got it, out of section. So I have, ignore the dot.
Is your mom listening, Jill? All right, well, Jill's mom, if you're listening, Jill's doing a really good job out here. And we're glad you're watching. Of course. Shout out to Jill's mom. For those of you just tuning in, we're working on figuring out exactly where we are. We use a combination of maps we have from last year and the depth, and of course visuals on the seafloor, what we can see. You're only getting to see one camera view, but we have 4 camera views in front of us, plus we have sonar, a forward-facing sonar on the vehicle, which can tell us if there are large outcrops or structures in front of us. And we have 3 screens that have things like battery power left, cable paid out, which lights are on, basically the diagnosis of how the vehicle's doing. It's a lot of things to look at, so we have 3 members of the Nereus team doing that, and we have 3 scientists helping as well. Some more beautiful white microbial mat. Do you remember looking at our table? What is that, Thiothrix? You don't remember? Somebody asked me on Twitter. I said Thiothrix, I couldn't remember. But it's not Vegeotoa, I know that. Yeah, I think so. We sequenced 2 little samples, and it's almost a monoculture. There's other stuff in there, but most of the sequences belong to this 1 or 2. We haven't looked at it that carefully yet. But they don't look like they are hot organisms. They look like they're cold organisms, which makes sense where we see them, right? Yeah, they're usually not around fluid flow. Yeah. I think the best descriptive paper I'd seen was from Icelandic hot springs, Icelandic cold springs, where they'd seen them. So the other way we're navigating down here is we have something called ultra-short baseline navigation. We basically have a pole that's sticking out the bottom of the RV Falcor, and then we have a beacon on the vehicle, and we try to get them to talk to one another to help us figure out where we are. But this is a type of navigation that works better in shallow water, and we're in very deep water. And Nereus can also wander very far from the vehicle, so this doesn't always work that great. You can see we're coming into black smoke to the right of the vehicle, a really large area of anemones and shrimp. Where there's shrimp, there are usually vent fluids. And as I mentioned before, last year when we collected one of these anemones, it had a shrimp in its gut. So not only is it feeding probably on particulate bacteria, but also on shrimp and other small zooplankton, perhaps, in the water column. Turning to the right here, facing almost due south, or at 4956, probably just above it, or just below it, excuse me. You can see that shimmery flow there. That's from the diffuse venting, where the hot hydrothermal fluid mixes with seawater. All right, we just broke 50 viewers. It's pretty remarkable that we can have live video feed from 5,000 meters beneath the ocean back to you anywhere in the world. That's the way ocean science is going, trying to bring more of what we do back to the world. That is all microbial mat, anemones, glued onto those rocks. Last year we tried to vacuum up the anemones and our vacuum wasn't strong enough, so we had to pick them off hand by hand. Claw by claw, I guess I should say. Manipulator arm by manipulator arm. For those of you just tuning in, we're at the Piccard hydrothermal vent field. We're at 4950 meters on the Mid-Cayman Rise, located about, I don't know, how many miles south of Grand Cayman Island are we? If you look on a map and you see the big island of Cuba, we're south of that. Way beneath the ocean. I was close. I was close.
What did you say?
Thiothrix.
Yeah, and then 4% of Theohalophes.
Okay. Cool. We are at a site called BB Vent Mound. That's a BB as in William BB, right? Who was, what? Oh, right, the naturalist. We also have a BB Woods in Woods Hole, Massachusetts. He was a famous naturalist and played a really important role in discovering and describing the natural world. Up in Woods Hole, we have some conservation land named after him, and now he has 3 vent fields, 3 vent sites named after him at the Piccard hydrothermal vent field. A lot of people ask, how do you name these sites? And whoever finds them first gets to name them, and it's usually a conversation in the control van or in the submarine saying, hey, that kind of looks like a snail, let's name it Snail Vent, or let's name this vent in honor of a certain person.
Well, no, there was a very distinctive little thing on the top of it. So.
We're up at 4952, 4951 meters. Moved away from the venting a bit. Just doing some exploring here.
Still want to keep going with this.
Casey to my left, he's the Nereus pilot for this dive. Jill is to my right, she's the event logger, recording everything we're doing, typing it into a database so that we can search it later, match it to the video, match it to our samples. James and Chris are off in the corner, staring at maps, helping navigate our way across the seafloor. We're pushing our navigation to its limits, our ultra short baseline navigation. Because Nereus has a pretty thin fiber optic cable, it can wander quite far from the ship. So even though we know where our ship is, that doesn't necessarily mean we know where our vehicle is. So we use a combination of depth and maps and terrain and visuals to help us find our way. You can see some smokers in one of our brow cams that you can't see, but it's just one of 4 cameras that we use to help find our way. We can see the BB vents off in the distance.
They've already knocked the chimney down. Like they have, is the one on the left there, is the one we want to solve. Number 1.
These vents are cleverly named. Oh yeah, that's beautiful. Cleverly named BB vent 1, 2, 3, and 4, and 5, I believe. There's 5. It's too bad you guys can't see this. It's really beautiful. We're going to try to bring the vehicle up to the right depth so you can see it as well and position ourselves for sampling. But in front of us are, 4 beautiful black smokers. And there you go. You can see it now just in the top of your screen. We're going to up our lights so that we can see better. Ah, nice. We just switched our camera feed so that you guys can see what we're seeing in the brow cam of Nereus. You can see that. Now it's on the high def cam, so we're going to switch it back. We're going to position ourselves to try to sample this. So these fluids coming out of this chimney are about 398 degrees Celsius. That's about 750 degrees Fahrenheit. The reason they can be that hot and not boil away is because of the pressure that raises the boiling temperature of these fluids. So we're bringing Jeff Seawald in to sample these fluids. Everyone's excited to see black smoke. It's really, really pretty. So you can see that parts of these chimneys are covered in shrimp. These chimneys are actually kind of leaky, and when that sulfide leaks out the side of the chimney, it mixes with seawater and makes a warm, low-temperature fluid. That's where the shrimp go. If they go in that black smoke, they get cooked. Cooked in metal-rich fluid, so they probably don't taste very good. So here we are, the BB vents, black smoker chimneys, BB chimney 1 through 4, gushing out 750 degree Fahrenheit fluid. Spires, what? Well, 398 degrees C, approximately. So right now there's a, pardon? Oh. Right now there are a lot of people in the van. So once we found the smoke, they all woke up. So we have almost our whole science party in here. We're only a science party of 9. I think the only one we're missing right now is Cindy, but she's across in the library where we also have a video feed, so scientists can and crew and anybody can watch from their bedroom, from the gym, wherever they are
So
on
how
the ship
hard
today.
is the bottom of this? Can I like go up against it without knocking it over?
Not necessarily. Not good. Depends how recently it was knocked down. We know of different submariners here recently.
Does that make it better or worse?
It could be very friable.
Oh.
This is a.
Yeah.
See those
things that-
little tiny chimneys? Oh, those are cute.
I think the orange stuff, if it's orange, it's been around long enough to go rusting off. You've got to hope that that's solid.
The path for these fluids to make their way out of deep in the seafloor to the surface is complicated. We actually don't understand what's happening beneath the seafloor all that well. All we really get is a surface expression of the venting, and we can measure it and make inferences about what's occurring beneath the seafloor. So that's the sort of thing that Jeff and his student Jill do. And then also in the van we have Chip Breyer, who's a geochemist at HROV, who's interested in, once it exits the seafloor, what impact does it have on the water column, the microbes down there, the mineralogy. You can see us just barely rubbing up against this chimney, scattering some shrimp, moving ourselves up, trying to position best we can to get a good sample. Up we go. Some people ask, how do you find a hydrothermal vent in the first place? Well, 4 years ago, was it 4? 9, 10, 11, 12. 4 years ago, this same team, we came out here and we scoured the water column using something called a CTD, looking for particle anomalies, temperature anomalies in the water column. And we found this site, basically did I think in one cruise we did something like 58 CTD casts. And then we came back, we gave those coordinates to our British colleagues, and they put a towed camera down in the region, and they sighted the black smokers. And then we came back with another remotely operated vehicle in 2012, last year, Jason ROV, sampled them, and now we're back here with yet another vehicle, Nereus. So this site has seen a lot of deep submergence vehicles. The British vehicle, the Japanese were here yesterday. Nereus, Jason, a towed camera. And they were only just discovered a couple years ago. But they're extremely interesting because of their great depth and also where they're located in the Caribbean. These are the first high temperature hydrothermal vents discovered in the Caribbean. And so our team has geochemists, biologists, geologists, microbiologists. We're all here to get a complete picture of what's happening at this pretty awesome ecosystem. And right now the pilots and navigators are working together to position themselves so we can pick up a sampler and reach out into that black smoke and take a sample. You can see the water is extremely cloudy. Shrimp don't seem to mind. Again, these are one of the reasons this site is so interesting is it's kind of a biogeographical question mark. In the Mid-Atlantic Ridge, we have hydrothermal vent shrimp commonly found. Vents of the East Pacific, we have tube worms and no shrimp. And the question, one of the driving questions for coming here was, what kind of animals do we see here? And the answer is a little bit of both. We see shrimp. They appear to be related to those found in the Mid-Atlantic Ridge. And we also see tube worms, but they're not related to the kind we see at the hydrothermal vents of the East Pacific Rise or the North Pacific. They look more like worms that are related to those found at hydrates and methane seeps, like in the Gulf of Mexico. We're moving up. Oh, there's another beautiful shot of those little mini chimlets, I believe that's what we call them. And a little bit further up, you can see these pipe-like chimneys, very friable. So if we were to touch those really tall, skinny chimneys, they would fall right over. Which is why when we were looking at the seafloor, we saw lots of pieces of long, broken-off sulfides. Our target for sampling is this one that's it's the largest pipe organ, just gushing out 398 degrees sea fluid. We're trying to get in the best position to sample them. It's hard to sample because you have to use the vehicle's thrusters to stay in place. It's pretty spectacular. Oh, beautiful. That's a good position. Casey's trying to find the best spot where he can actually hold on, stay in place, take these fluid samples. We need to be able to not move for a couple of minutes to fill the samplers. It's a very delicate operation. But that's a great pipe to sample. Oh, look how pretty that is. When hydrothermal vents were first discovered, scientists were actually looking for the missing heat in our global heat budget. When they were calculating how much heat they had on Earth, they realized there must be some extra heat leaking out someplace. And they saw these long features and cracks in the seafloor and decided maybe it's leaking out there. And that's how hydrothermal vents were discovered in 1977. You can see we have a lot of smoke in our field of view, which makes navigating challenging. But right now we have everything in front of us. There's nothing behind us to be concerned about. Just as long as we have the smokers in view, we should be safe. Again, we don't want to melt our fiber or anything else on our vehicle, like that plastic tube hanging off the front. Wow, it's quite a view. I keep wanting to shout frame grab. Frame grab. You want to sit here, Sean?
Thank you.
Jeff? Okay. Well, you're stuck listening to me. Jill's mom, are you still there? Text your daughter. She wants to make sure you're watching. It's not going to get much better than this. Linda. Yeah. I also know my lab back in Woods Hole is listening.
You hit the clock, Mario.
I believe a lot of people in Woods Hole are watching right now. What we're doing is just trying to get the vehicle in a stable position. You can see we're a little bit using the basket to kind of wedge up against the sulfide down there at the bottom, trying to get in a safe position where we're hopefully won't get pulled off. one nice thing about Nereus is that it can't get tugged the way a vehicle with a heavy cable can. The fiber optic cable coming out of the back of it is looks like a fishing line, but that very thin fiber optic cable is how we're getting the video you're seeing. It's how we're getting all our telemetry. It's pretty remarkable technology. My brother's listening. Hi, Greg.
Somewhere in the black smoke.
Yeah, the hottest. Oh, I mean, that's all hot, so I'll just guide you with a couple, tell you when.
So we think we're in position. Are we in position, Casey? We think? Okay, fingers crossed, he says.
All right, let's do this.
So start with the number 7. That's your sampler.
Is this 57? 58.
Now you have a view of the basket off to the right. Those two large titanium cylinders you're looking at are Jeff Seawald's IGTs, isobaric gas tights. My brother is telling me that I should point out that the arm of Nereus was built by a family member, by Matt at Hui. So now that the vehicle's locked in, Casey has switched over to the arm controller, turning on hydraulics to the arm. Since we're on battery power, we only turn on things as we need them. Yeah, so we want them to see that one down on the bottom right. So we have 4 different views off of Nereus. You can only see one at a time. We can switch for you. Right now, we have a basket view, which is the best view for Nereus, to go and pick up one of these isobaric gas tights. These samplers were designed and built by Jeff and his crew. And what they do is they can collect fluid. They have a temperature sensor at the end of them. And they keep the fluid at the pressure they were collected at, even when we bring them to the surface. And that's really important if you're interested in gas, because all those gases will dissolve as you move to lower pressures. So as we move from 5,000 meters up through the water column, they would disappear and you wouldn't be able to measure them. But because the fluids get kept at the temperature they're collected, you can measure them. So you can see the arm moving across the basket. We're going to try to pick up the IGT in the back of the basket. Which IGT is that?
I think it's 7.
IGT number 7. So your view of the black smoke is blocked a little bit right now. That's one of the cameras we have up above the arm. Again, in the van we have 4 different views. And we can switch between them depending on what the pilot needs to do their job best.
Looks like you have it.
Brian Midson from NSF wants a shout out, so I'll give him one. Brian's watching from Arlington, Virginia. Yeah, you can request shout outs via Twitter or by texting me. All right. So we're preparing to take IGT number 7. Now we can See the label? You can see the little snorkel churning it. It's a really beautiful view of the chimneys. I like that camera. Can we pan? There we go. We caught on the cable.
Looks like it's breaking away.
What's breaking away? Oh, back on the vehicle? Okay. Can we switch? Do you want to switch back to this camera? The one that Casey has? All right. It's quite a view. We're trying to position the sampler right in the flow. And we have Jeff in the back of the room looking at the temperature sensor and using that to help guide. Obviously, we can't see where our sampler is right now. So we're going to use temperature as our guide. Oh.
Yes.
All right, so now we're trying to get the snorkel into the orifice of this vent. Trying not to melt our cable. Pardon? Ah, I see. They'll be bored 350 days out of the year. So again, we're positioning one of Jeff Seawald's samplers here at BB Vents. This is BB number 1, I believe. And we have Jeff Seawald in the back of the room, and he has temperature probes.
How about your cable? Can that fit in there?
No.
No.
So you're going to have to refresh
Okay, so
reset.
in about 2 minutes, everyone will need to refresh their browser. We're going to have to change the stream over. So if your screen goes blank, we just need you to press refresh. That's because we're storing this video in 30-minute packets, right? Oh, sorry, 4-hour packets, and we've been on the seafloor for 4 hours now. We launched the vehicle at 4 a.m. this morning. It's 11 a.m., so the vehicle's been in the water for 7 hours. Looks like we've used about 30% of our batteries.